All right, one last video for class 5. Here's a example out of Cengel where we want to determine the mass of the air in a room with the dimensions of 4 by 5 by 6 in this room right here at 100 kilopascals. I'm guessing this is absolute because that would be really high pressure to be inside of a room that would have this as a gauge pressure. And 25 degrees Celsius, which is pretty close to what most people use for room temperature of like 23. And so, write out what our given is. We have the volume of 4 by 5 by 6 meters. And so that's 120 cubic meters, right? Does that make sense? Sure. So that's maybe 20 times 6. Yep. And the pressure is 100 kilopascals, assuming absolute. And the temperature is 25 degrees Celsius, which is going to be 298 degrees Kelvin. And we want to find the mass. So we look up R is equal to 0.287 kilojoules per kilogram degree Kelvin. And then we apply PV equals MRT. And so we can find M by taking P and V and dividing it by R and T. The pressure, let's turn that into newtons per meter squared. The volume is already meter cubed. I like to R to be in Newton meters. All right, so we need to have 1,000 of them, so we go 287 Newton meters, which is energy per mass and per temperature. And then go through the temperature, which we have to make sure we had turned it into absolutes scale, which is this. And for a mass, we get 140.3 kilograms. And we have ourselves an example, an extra example, but it's kind of a simple example, right? We're going to build upon the complexity in class 6 because we're going to go into a compressibility factor that we have to include. But these ones are pretty simple ideal gas law. Check out the video that was just before this for the demo of messing around with the ideal gas law. See you soon.